So on this problem, the farmer wanted to fence in an area that was adjacent to a river, so he did not need any fencing next to the river. Your area is xy. The perimeter is x plus 2y. It's not 2x because we don't need the side by the river. So when you solve the perimeter formula for y, you get y equals 400 minus x over 2. And then what you want to do is plug that back into the area formula here, and then simplify by multiplication, and then reduce by division of 2. So you have 200x minus 1/2 x squared. And the first derivative of that would be 200 minus x, which you set equal to 0, and that's really convenient. It comes out to be 200. And then plug in that 200 here for the x, solve for y. Should get 100. But there's no calculus needed for this. It's just a simple math problem. You have a surface area of 1200. The formula for the surface area is 4 pi r squared. It's in one variable. There's no calculus needed. Plug in and solve for r. 9.7721. Once again, the objective is to use calculus to solve optimization problems. Here's example 1, which might as well be called volume 1. A farmer wants to enclose a triangular area with 1,300 square feet of fencing. One side is adjacent to a river and needs no fencing. So this problem isn't anything different than what we've done before. The only thing different is that you have a triangular area. So it's triangular next to a river, 1,300 feet of fencing. It's adjacent to the river, so you're only going to have two sides of the triangle. What dimensions will maximize the area? That's what we're looking for. So here's a river, and beside that river there's going to be a triangular area. So we'll make it look like this. We'll have x, y, and the hypotenuse is a conjunction of x and y to solve for hypotenuse. So the hypotenuse is the square root of x squared plus y squared. And I think we've been through that before. So from there we continue on. So here's the original problem, and we found x to be 433 and a third. So this is 433 and a third. We don't need y as a final answer in terms of how much fencing we're going to use, but sometimes if it's a right triangle you might need that in order to create the right triangle when he's building this. But what we do need is this one here. We do need that side.
With the cafeteria ladies today, these. I need these students in Miss Collier's room for lunch detention. Chase Thompson.
So once you have your y value and your x value, you can plug those in to here to come up with that missing hypotenuse side for your final answer. Write what you know on these problems. Don't leave anything to chance. The perimeter is going to have to be 1,300. That's how much fencing you're going to have. And the area is 1/2 x times y. The perimeter is x plus the square root of x squared plus y squared. Don't throw y in there. If I throw in y by itself, what mistake have I made? You're calculating a side that's y. It's gone. We don't even use it. It's by the river, so there's no need for it. This is the only amount that you're going to need. So set perimeter, the perimeter formula, equal to 1,300 and solve for y. So there's the perimeter formula, set equal to 1,300. To solve for y, you're going to have to move that x over to the right side, change the sign, and you need to get the x squared, y squared underneath the square root sign by itself. so that you can square both sides and get rid of that square root sign. So that's why we moved this here, and we've put a square on both of these now. Because when you take the square root of the square root of x squared plus y squared, it disappears, or unless it's out of order. It comes out to be this: x squared plus y squared on the left, and then of course you have to expand out the 1300 minus x quantity squared on the right. And just use the first outside inside last from 9th grade. This is going to be 1,690,000 minus 2600x plus x squared. Not a major deal so far. So what you can do from here to simplify is, notice you have an x squared on the left, x squared on the right. Just cancel them out, because if you move one to the other side, they just turn to 0. So from there you end up with y squared equals 1,690,000 minus 2600x. Now of course you're going to have to get y by itself, which it isn't yet. So there it is with y squared, but you need the square root of both sides. And when you do that, the y is now by itself, but you have the 1.69 million minus 2600x under the radical sign on the right. But nonetheless, we have still solved for y. So at this point, we can go in here and do the square root of 1.69 million minus 2600 times 433.3 repeating, and come up with a value for y. Right. 750.
Today, the cafeteria's computer is down.
0.555.
So you cannot get any
35.
extra food. You can just get what's on the table.
So substitute into the area formula. This isn't anything new. This is what we've done before. So the area is 1/2 xy. We just solved for y. So we plug in what we solved for. And now, so we have to find the derivative of a. Factor out constants first to make this simple. So you have a half that was with that. Notice that I put the half outside, and that the x is on the outside of this quantity on the right here. It's the same thing we just had. We're finding the derivative, so starting now we're going to use a different notation on derivative, which means this. Anytime you see this in front, sometimes it could be behind. It depends on who's writing it. You have to see the pattern, but in this case I'm telling you, in the front, that means you're going to find the derivative of what comes after that. So that means the derivative with respect to x. And don't forget, this is a quantity, and this x by itself is 2. So you have to use something called the product rule in here, and this is the first new thing you're going to look at. The product rule means you have two items here for which you need the derivative, but they're multiplied together. So use the product rule. Here is what the product rule is. The product rule is written in general form here, but let's say you have two items, u and v. And in our case, that would be the radical sign and then the x. So think of it as the u being that radical sign with the 1.69 million in it, and the u being the x term. So what you do is you start by writing whatever your v term is and multiply it by whatever the derivative of the first term is, the u. And then add to that u by itself multiplied by the derivative of the v term. And you'll see on the next page coming up, it's much easier once you see it done with the actual problem we're doing. So in simpler language, you have your first item times, or actually your v item times the derivative of u, plus your u item times the derivative of v. Maybe that looks a little better for understanding. But in terms of the actual problem, here it is coming up. So here at the top, remember we had the half that was taken out? So this was our v term. We made x the v term. So according to the product rule, it's written by itself, and it's going to be multiplied by the derivative of the radical term with the 1.69 million in it. But keep all this separated in parentheses, because remember you have a half out there to the left. And the plus sign, according to the product rule, you have to do the radical sign term just by itself, and then multiply it by the derivative of that x term. So in general, you can't go wrong if you use the product rule by just dividing up your two items just as 1 and 2. You could even have done this separately. This here could have been out front, and then this could have been around back. You could think of the product rule as your first one times the derivative of the second one, and then plus your second one times the derivative of the first one. You just alternate them. Now we have to use something else called the chain rule. And this pops up when you have something like a radical sign in there that you need a derivative of. Here is the chain rule. The chain rule is you're going to have the derivative of the square root of u, and then you're going to have just the derivative of u. And this makes hardly any sense just in general form, but I'm obligated to give that to you, but we're going to look at it in much simpler terms coming up next. So in other words, it's this. You're going to end up with an item that looks like this. 1 over 2 square root of u. So here it comes. And look at the difference between the blue and the red, and I'll go through it with you. Notice that we had the radical sign over 1.69 million minus 2600x. That's what we started with. What you do to simplify this when you're getting a derivative of that is to leave the item that's underneath the radical sign on top, and you will find the derivative of that item. And then on the bottom, what you will do is move what you had from the top to the bottom and put a 2 out to the left of it. So once again, here's what we started with here. We have this item. Remove what's under the radical sign and keep it on top in the numerator, and find the derivative of that. And then on the bottom, you want to put what you originally had here, except with a multiplication by 2 beside it. So in this example problem, we're learning 2 new things, and there's also something called the quotient rule that we'll go through here in just a little bit. Now, off to the side here, notice what we still have. We still have all of this here. That's intact, and so is this. We haven't done anything with that yet. This or this, it's still the same. So now we'll move down to the dark green here, and notice what's changed from red to green. The only thing that's changed from red to green is what? Yeah, we have the 1, and where did the 1 come from? The derivative of x is just 1. The derivative of x is 1. So that's the only thing we've changed. Everything else is similar. So when we went from red to green here, the only thing that changed was the derivative for x. We made that a 1. And now from the green to the blue here, what has changed is that we've eliminated the 1 because it doesn't change anything. And notice that we have a difference up here. You're finding the derivative of the difference of 1.69 million, which of course there is a 0 left off in that little spot there. So I'll go ahead and put it in right there. I just happen to leave a 0 off. But since you're finding a derivative of a difference, you're going to split them up and find the derivative of each one. The derivative of a difference is the difference of the derivatives. So that's what's happened right here. Whoops, I just marked over that for no reason whatsoever other than I didn't have my laser pointer. So it's not gone. This is just what we've done here. We want the derivative of this, and we split them up as a difference. That's the only thing that's changed from here to there except for the 1. And we still have another step to go on this screen here before we go to a new one. Alright, so going from here down to here, notice what has changed. You still have the x term here. Notice that it's gone all the way down through here and has not changed. It still stays with it. The derivative of a constant is just what? The derivative of a constant is 0. So there's the 0. And then over here we haven't changed this yet. It's still the minus 2600x. And notice that the 2600 will stay, and we will find the derivative of the x, which will turn out to be 1 eventually. And then this has stayed the same, and so is this. Alright, so here's where we're at on this screen now. So we end up with a minus 2600x on top here, and that's all that's happened so far from the last screen to this one. Now, from this point to the next line, here's what happens. Where did we get the negative 1300x from? How did that appear? Yeah, half of it, because you have a 2 right here. You're dividing by 2, so you can cancel that and make it as simple as possible, a negative 1300x. And everything else has stayed the same in the problem. I've worked these out one bit at a time so that it's not extremely fast and too confusing. Okay, so from the point where we found the minus 1300x, we go to the next line and come up with the following. Alright, so we've done what to get rid of the parentheses? Yeah, we multiplied everything by a half. So we've multiplied this by a half and this by a half. So that gives us a negative 1300x over 2 times the radical sign quantity, and then plus radical sign quantity over 2. Now we're getting close to where we can do something with this. Do we have any more derivatives to find in this expression? No, they're all gone. The d's over dx's are all gone. So we'll set everything equal to 0. And this is what it looks like when it's equal to 0. Now, what would be your first choice? What's your first movement in solving for 0 here? Does anybody want to take a guess?
Get rid of the radical in the denominator.
You can do that, and the next step I'm thinking about will actually do that. Usually when you have, let's say if you had x plus 2, or not x plus 2, what if you had x over 3 minus 5 over 10 equal to 0? What would you move over to the right? Yeah, the minus term, the minus 5 over 10, and then create something that you can cross multiply. So how about we do this? we have a negative term here. So why don't we move that over to the right and it becomes positive. So now we have kind of a proportion thing going here. And what would happen if I multiplied this radical term by this radical term? The radical sign would be gone. It would just be gone. So look how neat this works out. If you cross multiply from here to there, you're left with this. If I cross multiply here, I'm just left with this. The radical sign is gone. If I cross multiply here, I have 2600x. So now I have a much simpler equation to use. What's my next term? Or not next term, but next move? Yeah.
You had 2 in the denominator. On your right, you had divided by 2.
Yeah, I just left out a 2 here on this one, from there to there, and we've put that in at this point. So from there, what should I do next? Multiply through by the 2. So if we multiply through by 2, what do we end up with 2 times this item there? Should be 3, 3, 8, and then 4 zeros. And then when we multiply by 2 here, we end up with minus 5200x. And then we'll have equals 2600x. So from that point, we can keep the 3380000 and move the 5200 minus 5200x to the right side and make it plus 5200x. And that would give us a 7800x. Alright, from that point, divide the 3,380,000 by 7,800x and come out with a value of what? Yeah, 433 and a third. Now that's what we can hold at this point, and then go back and look at the original setup with the diagram and then plug it back in.